Ocean acidification happens as the rising carbon dioxide levels dissolve into the ocean, and as a result, the water's pH lowers. When carbon dioxide is introduced to seawater, this chemical reaction occurs. This results in decreased levels of carbonate ions. Carbonate ions are naturally in the seawater and are essential to numerous calcifying organisms. As the ocean acidifies, the carbonate ion concentration decreases as it is joined with hydrogen ions to form bicarbonate molecules, and therefore no longer available to use by marine life. Copious amounts of calcifying organisms rely on the abundance of these ions to create and maintain their shells that protect them and allow them to survive and reproduce. However, other organisms, especially ones that require carbon dioxide to photosynthesize to create energy to survive, will thrive in this type of environment. When the ocean becomes more acidic, even the smallest changes can cause the most catastrophic damage, especially in the Great Barrier Reef of the east coast of Australia, where so many organisms need carbonate ions to survive. When the organisms at the bottom of the food chain are affected, there are countless side effects that will work its way up, affecting virtually everything, including mankind.
A survey of 2,500 members of the public, posted by the Journal for Nature Climate Change, has revealed that just 1 in 5 people are aware of ocean acidification. While public awareness of climate change is now almost universal, the same cannot be said for ocean acidification. Researchers also set out to assess whether scientific reports published by the Intergovernmental Panel on Climate Change during 2013 and 2014 have affected levels of public awareness of ocean acidification. These widely reported assessments focused more than ever on the role of oceans in relation to climate change, but were found to not have raised awareness of ocean acidification among the general public. Understanding public awareness, concerns and priorities is important to appreciate how people relate to climate change issues, how science-based conceptions or misconceptions are viewed amongst the public, and understand how societal perceptions make policies more responsive and accountable to public values. Currently, the best way to minimize the impact of ocean acidification is to decrease anthropogenic carbon dioxide. There are several opportunities and initiatives that local businesses, stakeholders, tourists and the state and federal governments can adopt to contribute to the reduction of carbon dioxide emissions and eventual immobilization of further acidification. Nationally, large businesses and state and federal governments must adopt a uniform framework for combating and minimizing anthropogenic carbon dioxide emissions.
It has been suggested that placing a sleeve of water and nickel around the stacks of large power plants will allow the CO2 to be captured and stored. Using the resultant calcium carbonate in cement, for example, could in turn help reduce the large amounts of emissions caused by the mining of limestone used to make cement, essentially solving two problems at the same time. To help reduce ocean acidification, why not look at the animals and organisms that it is affecting most? Sea urchins, among other organisms, use high concentrations of nickel in order to capture carbon dioxide and then use it to build their calcium carbonate skeletons. If this concept works in nature, why couldn't it work for human industries?
It is imperative that future economic growth is simultaneously developed with consideration to environmental impact. This process is called decoupling. The first step of decoupling is peaking our current emissions. This can be done by designing the future with commitment to asking the underlying questions and fulfilling the optimal results. Everyone can do their part by reducing and making those little changes to everyday life. Individually, we can help decouple CO2 emissions and in turn ocean acidification from our everyday lives and still be able to maintain and improve the quality of life that we are used to.
To combat ocean acidification, the amount of carbon dioxide that is released into the atmosphere needs to be reduced. Carbon dioxide capture and storage, or CCS, can help combat this at the source in 3 major steps: capture, transport and storage. Firstly, the CO2 emissions are captured directly from power plants, heavy industries and refineries. Secondly, the CO2 is then transported and compressed, usually via pipelines. And lastly, it is then injected into the earth into specifically selected geological rock at depths of 1 kilometre or greater. Carbon capture and storage can capture up to 90% of the CO2 emissions that are produced from the power plants, heavy industry and refineries. The development of capture technologies has provided ways to separate the carbon dioxide from other gases. The US Department of Energy estimates that anywhere from 1,800 to 20,000 billion metric tons of CO2 could be stored underground in the United States alone. That is equivalent to 600 to 6,700 years of current level emissions from large stationary sources in the United States.
An effective use of whole system design is to harness renewable energy. The well-being of the Great Barrier Reef relies on humanity developing without fossil fuel dependent energy sources. Renewable energy can be harnessed in many ways. The three most emerging include wind energy, solar energy, and hydroelectricity. Renewable energy sources are proving a promising future development, with the ideas of advanced silicon-based solar cells and further innovation in design materials. Implementation of wind and solar farms is an essential replacement to coal and fossil fuel mining. The United Nations have claimed that humanity is destroying forests at 170,000 square kilometres per year. If solar panels were being constructed at this rate, the Earth's energy crisis would be resolved in just 3 years. As most of the renewable energy harnessing concepts are only in the early stages, there is a massive amount of potential in this area. Renewable energy sources paired with battery storage is a crucial innovation strategy that could develop further optimization in this area. Renewable energy should be a concept that Australia is further developing, and an approach that humanity undertakes at a national as well as a global level.